Starting air system. Starting air system of a large reversible diesel engine will be discussed in series of lectures. Here in the first lecture we will be discussing the fundamentals. Here is an engine shown in a stopped position. Whenever a turning engine comes to stop, turning in ahead or in astern direction, comes to a stop, the engine can take one of the innumerable positions that are possible for it to take around 360 degrees of the crank angle, around 360 degrees of polar axis of the crankshaft. No matter in whichever position the engine may have come to stop to, the starting system of the engine should be designed to give to the engine a start moment and turn the engine from that stopped position in ahead or in astern direction and make the engine attain a good momentum so that fuel now injected in its units can catch fire. Most large diesel engines use compressed air to give to the engine the required starting moment and make stopped engine attain the required momentum for the injected fuel to get burnt. This is called starting air system of the engine. Now that the engine is shown in a particular stop position, the relative positions of the piston 1, 2, 3, 4, 5 and 6 is further decided by the firing order of the engine. The firing order of this engine is 1, 5, 3, 6, 2, 4 for anti-clockwise, that is ahead direction running. It means at this stop position, if number 1 unit piston position is just past its top dead center, and if there is a movement of number 1 piston downwards, its crank pin and the crankshaft will turn in anti-clockwise direction. As number 1 crank pin will move, the number 5 crank pin will take its place, and subsequently the number 3 and 6 and 2 and 4 crank pin and so on will take this place. This is what gives to this engine a firing order of 1, 5, 3, 6, 2, 4 for ahead direction, anti-clockwise direction running. At this instant, with the engine shown in a particular stop position, if compressed air is released on top of number 1 piston, the compressed air will push the number 1 piston down, creating a turning moment at number 1 crank pin for crankshaft to turn in anti-clockwise direction. The turning moment created at the number 1 crank pin for crankshaft to turn is the product of pressure of the air on piston top, area of the piston, and the distance of number 1 crank pin from the center of the crankshaft. This turning moment will gradually increase as the number 1 piston keeps traveling down. Soon it will be number 5 piston that will be just past its top dead center and its crank pin in the position held earlier by number 1 crank pin. If compressed air is now released in number 5 unit and turned off in number 1 unit, the number 5 piston will get pushed down, causing a turning moment at number 5 crank pin for the crankshaft to continue to turn in anti-clockwise direction with increased momentum. If compressed air is continued to be admitted on top of pistons one after other in the firing order of 1, 5, 3, 6, 2, 4, the engine will continue to get turned in anti-clockwise direction and will attain increasingly higher momentum. Admittance of compressed air into units in orderly fashion is continued till the engine attains a good momentum to cause ignition of the fuel injected in the units as per the same firing order. Any starting air system will therefore have at its core firstly a network of starting air pipes connecting starting air of 30 bar or so from starting air receiver to the cylinder starting air valves placed one on each unit. And secondly, a starting air system should have a mechanism to confirm that every time an air kick is given, During the kick, the air is admitted in the engine at the appropriate cylinder, one after other in its firing order. In the engine shown here, the starting air lines taking 30 bar starting air right up to each cylinder starting air valve is shown in color blue. We have here cylinder air starting valve 1, 2, 3, 4, 5 and 6 for the 6 units. And for a mechanism to confirm that at this instant start air is released in only number 1 unit and thereafter in others as per the firing order, we have starting control valves, one for each unit. Each starting control valve is operated by its cam. Cams are placed on a camshaft called starting air camshaft. Starting air camshaft carrying cam 1, 2, 3, 4, 5 and 6 is driven by the crankshaft through a gear mechanism. The control air lines to and from the starting air control valves are shown in color light blue. Plunger inside each starting control valve is held up away from its cam by a return spring. However, during the starting air kick, the plungers are forced down on their cams by the control air. Depending on where on the cam profile the plunger lands on being forced down, a plunger will either travel further or travel no further. The plunger that is forced on depression of its cam profile has traveled down and allowed the control air pass on at its starting control valve and pressurized control line leading to its cylinder starting air valve for it to open. Cams of other plungers will however keep plungers from moving further down and keep lines leading to respective cylinder starting air valves vented to atmosphere. At this instant, as shown in the figure, number 1 starting control valve plunger is pushed down on the depression of its cam profile and control air line leading to number 1 cylinder starting air valve is pressurized, while control lines leading to number 2, 3, 4, 5 and 6 cylinder starting valves are getting vented to atmosphere. Therefore, at this instant, when air kick is given, number 1 cylinder starting air valves will open, engine will turn, subsequently number 5 starting control valve plunger will get pushed on depression of its cam profile, making number 5 starting control valve release control air into the line leading to number 5 cylinder starting air valve for it to open, and so on. Engine will soon attain a good starting momentum. The starting air kick can be stopped and fuel is admitted in the units for it to ignite and provide power on the engine. The air kick has to be long enough for engine to attain a good starting momentum before fuel is injected. The start momentum on engine should give a good RPM on the engine to confirm firstly the pistons are going up and down fast enough to cause charged air on top of pistons get compressed and heated up to a good temperature to cause ignition of the fuel being injected in the unit. And for engines where fuel is injected in the units through the injector by jerk fuel pumps, the RPM of the engine on air kick should be high enough to make fuel pump cams cause fuel pump plungers to accelerate up fast enough to cause them jerk and make fuel get pressurized high enough to cause fuel to get injected into units through the injectors in most atomized form. In engines where fuel is injected into units through injectors from a high pressure common rail fuel system, the starting air kick has to be sufficient to give a start momentum on engine just to make the charged air on top of pistons get compressed, heated up to good temperature to cause ignition of the incoming injected fuel. The required RPM to achieve this is lesser than required for jerk pumps to jerk the fuel. Hence, modern engines which use the common rail high pressure system for injecting fuel instead of using jerk pumps can run at very slow speeds without getting stalled. These engines provide to the ship a larger range of RPM between dead slow to full away. Fundamentals of starting gear system just explained is again shown in animation. Before we run the animation, do notice during the running of the animation the following 6 salient points. The number 1 point. Blue lines are showing the main starting airline, and light blue lines are showing the control airlines. The number 2 point. On giving air kick, both lines will get pressurized simultaneously. The air would be coming through the starting air valve, not shown in the figure, from 30 bar air receiver. Number 3rd point. Main starting air will reach all the 6 cylinder starting air valves, and control air will reach all 6 starting control valves on giving the air kick. Number 4th point. The 6 plungers of starting control valves will get pushed down on respective cams. Number 5th point. The plunger 2, 3, 4, 5 and 6 will soon stop getting pushed down as they have reached their respective cam base circles. However, plunger 1 will continue getting pushed down till it reaches its cam, which is the only cam of the 6 cams which is offering depression part of the cam profile to its plunger at this instant. So plunger 1 travels lower than rest, the number 6 point. Number 1 starting control valve thus allows control air to pass on to number 1 cylinder start valve, pushing the number 1 cylinder start valve down to open and allow main start air to enter on top of number 1 piston. Number 1 piston moves down, making the engine crankshaft turn in anti-clockwise direction, that is in ahead direction. Main and control air is released. Number 1 starting control valve pushed down, control air released. Number 1 cylinder air start valve pushed down, piston pushed down, engine turns. Checking the salient points. Control air release. Number 1 starting control valve plunger pushed down on the cam. Control air is released. Number 1 cylinder air start valve is pushed down, piston pushed down, piston turn. This is the starting air system of a large marine diesel engine.